guys, this is 5.5 scale factor. So we're going to start out just with the definition of scale factor, or what it is. It's the ratio between corresponding sides of similar figures. So we've talked about all of this stuff before. We just haven't explicitly talked about scale factor yet. So I think the easiest way to explain it is to look at some diagrams. So in this diagram here, we have triangle ABC is similar to triangle FDE. So I'm going to start off by writing the similarity statement here. So we have triangle, I'm going to start with the right angle and go up. So ABC is similar to triangle going in that same order, FDE. All right, so this one is a really easy, kind of obvious one, I think. If you look at, let's just start with like this left side and this left side. On the left triangle, we have a 3, and on the right triangle, triangle FDE, we have a 6. So to get from 3 to 6, you multiply by 2. And the same thing should be true for the other two sides. So our hypotenuse is 5, and then our hypotenuse is 10. So 5 times 2 is 10. And then the last one here are 4 and our 8. 4 times 2 is 8. So the scale factor in this case, we use the letter K to represent scale factor. K would be equal to 2. It's what you multiply by to get from the left triangle to the right triangle. And maybe we'll write that down. I think that's maybe even a better definition. What you multiply by to get left triangle to right triangle. And that's how we're always going to do things in this class. We're going to go from left to right. Okay. So some tips. If it's not easy, so this one was really easy. We could just look at it. 3 times 2 is 6. 5 times 2 is 10. 4 times 2 is 8. If it's easy like that, then you can just write it down. K equals 2. Easy enough. If it's not that easy, you can always divide from right to left. So what I mean by that is start at 8, go to 4, and divide. So you would literally write down 8 divided by 4, and you get 2. Or you could pick a different one. You could pick the 10 to the 5 and divide. So 10 divided by 5 equals 2. Same thing for the last one. 6 divided by 3 is equal to 2. So that's how I always do it if it's not just really easy to see. Divide right to left. Okay. Second thing, always check all of your sides. Okay. Sometimes you might be dealing with two triangles that aren't actually similar. And if you don't check all three sides, or if it's quadrilateral, all four sides, then you might be in trouble. So take the time to check all the sides. And then third thing, you can always use the letter K to talk about scale factor. You certainly can write out scale factor is 2, scale factor is 1/2, whatever. Or you can just use the letter K. That's kind of a common thing that we use in math when we're talking about scale factor. All right, so we're going to do a couple examples, and these are going to be really similar to what is on your worksheet and the mastery check, and finally on the test. So we have triangle STU, and we have triangle PQR, and this one, they're oriented the right way. They look like they might be similar. Nothing is twisted or flipped upside down or anything like that. So the first question is, are they similar? Well, in order for these two triangles to be similar, we have to basically have the same scale factor for all three sides. So what I do is I always start with the smallest side. So the smallest side is 6 on the first triangle, and the smallest side is 4 on the second triangle. And remember, my tip was always to divide from right to left. Okay, so I'm going to check 4 over 6, and I'm going to reduce that. 4 divided by 6, you can divide them both by 2, so you get 2/3. Okay, we can't go any further than that. You could type it into a calculator and you'd get like 0.66666. That's fine too, but I think the fractions are an even better way to do it. Okay, then I'm going to find the medium sides. So the next biggest side is 12, the next biggest side is 8, and I'm going to divide from right to left. So I'm going to do 8 divided by 12. And I'm going to reduce that. So 8 and 12 are both divisible by 4. So divide them both by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. So far, We have 2/3 and 2/3, so it's looking good. Let's check the last one. Let's check the longest sides. So we have 12 and 18. We're going to divide that way. So I'm going to do 12 divided by 18. Both of those are going to be divisible by 6. So 12 divided by 6 is 2. 18 divided by 6 is 3. Okay, so 2/3, 2/3, 2/3. So are they similar? Yes. They are similar because all three corresponding sides have the same scale factor. So we don't need to answer that question because they are similar. So if yes, what is the scale factor? That's just that number that we found. K equals 2/3. Okay, and that makes sense. Our triangle is getting smaller. We started out with 6, 12, and 18. We ended up with 4, 8, and 12. We have a smaller triangle, so it makes sense that our scale factor is less than 1. Anytime you're getting smaller, you're going to have a scale factor that's a fraction, somewhere between 0 and 1. Okay, and then lastly, write a similarity statement. So it doesn't matter where you start. I'm going to start with S. I'll go STU. So triangle STU is similar to triangle. Go in that same order, PQR. That's the end of example 1. All right. Example 2, I think this is the last one that we'll do. This is one that sometimes causes some confusion. I think some people are like, oh yeah, rectangles. All rectangles are similar. They're all the same shape, but they're different sizes. Well, sort of. But not exactly. Sometimes you can have really skinny rectangles and sometimes you can have really fat rectangles and they're not necessarily all similar. So we need to follow our rules. We need to check and see if our ratios are the same. So again, I'm going to start with the smallest side. So 6 and 3, and I'm going to divide backwards. So 3 over 6. 3, 6, both divisible by 3, so we're left with 1/2. Okay, and then your other sides are 8s. So we got 8 and 6. Divide backwards. So we have 6 over 8. Both of those are divisible by 2. So 1/2 of 6 is 3 and 1/2 of 8 is 4. And those are not the same. Okay, we have 1/2 and we have 3/4, and they are sadly not the same. So are they similar? No. And our reason is that our sides are not proportionate. And that's going to be your reason most of the time. Your sides, they don't work out. The ratio of one of the sets is 1/2 and the other one is 3/4, so therefore they're not proportionate. So if yes, what is the scale factor? Well, they're not. And if yes, write a similarity statement. They're not. So we're done. So always check all of your sides before you decide that something is similar. Okay. So in summary, to find the scale factor, or K, we're always using the letter K, divide corresponding sides from right to left. That's the biggest thing from this lesson, is to just pick out those corresponding sides, bigs with bigs, littles with littles, divide from right to left, and you should be good to go from there.